Hello everyone, so today we're going to be moving on to our next section, which is 12-3, and this section is about tangent lines. So in order to understand the theorem, so I have a picture to show you guys, so let's look at that first. So this is the first one. Let's start off with that. Okay. Now, if you guys already have this picture, this whole image in your textbook on page 876. So let me review this theorem number 76. What does it say? It says a circle O. If there is any tangent, a line that touches the circle at a point P. So here's the circle. And this line AB touches at point P. So what's true about that point? So this is what happens. So anytime a line touches the circle at a point P, so that line always going to be a perpendicular to the radius of circle. So if that's perpendicular to that radius, so it means exactly at point of tangency, there will be 90 degrees angle. Alright, so I repeat, so anytime there's a tangent line that's perpendicular to radius of the circle, so at the point of tangency, there will be 90-degree angle. And even its converse, I hope you guys remember that from Math 2 class. When I say converse means if I say this information other way around, it would work too. So let's say if I say, okay, so there's any line that makes 90 degree when it touches, so what's true about that line? That line would be a tangent to that circle. All right, so that's what we're going to be talking about that. So that was the theorem you needed to know. So let's look at my first example. So I do have a picture of that. So how about if I just bring in all the pictures you needed to know? So we have to have this, and this. And that's just done. Okay, so let's look at my first example. This is what we needed to talk about first. Okay, now do we see any tangent in this problem? So I see two tangents. So M to N, that's the first tangent, and ML is another tangent. So we already know those two are tangent lines. So what's true about the tangency point? So exactly at the tangent point, it would be 90-degree angle. So do you think we can solve for x degrees in this shape? This is a four-sided quadrilateral, right? So you know quadrilateral, all four angles are add up to 360. So can we solve for this fourth missing angle? So yes, we can do that. So one of the angle, 117. So other two, we just know it's 90 and 90, which is add up to 180 degrees. And if I add it to x degrees, you know that would be equal to 360. So let's solve for that. So if you add 170 to 180, it would be 297. And if I take away that from 360, so the angle x degree, which would be equal to 63 degrees. So that's how we do it, okay? If you see any tangent point and tangent lines in any circle, so you know exactly a tangent point, it would be 90 degrees, okay? So that's my first example. So now let's move on to our next part. So next is just the converse of the theorem I just said before. So even though we have talked about that before, but still, okay, let's do a review. So this is theorem number 77. So now it says, if AB is perpendicular to OP, so this line is perpendicular to OP. So what's true about that tangent point? So what's true about those two lines and the relationship? So the relationship would be, just because it makes 90 degree at tangency point, so it means that AB is a tangent to that circle, okay? So let's look at an example for that. So that would be, next example would be, where is it? Okay, so here's the example. So let's talk about this. So first I see 90 degree here, so it means this line is a tangent. If it's a tangent and if it makes 90 degree, and since we have three sides, so what type of triangle it is? It's a right triangle. If it's a right triangle, then what's true about all three sides? Isn't it Pythagorean theorem would work? So what this would be, c squared is equal to a squared plus b squared. Let's plug in for the sides we know. So this is, let me pick a different color. I don't know why I'm just kept using yellow. This would be the hypotenuse. So you know the longest side, which is always across 90 degrees, it's always going to be the longest side. So, and the other two just normal legs of this triangle. So one of the leg is 10, so I would say 10 square. The other leg, which is x, I would say x square. Hypotenuse is 12, so I would say 12 square. So let's just solve for that. 12 square is 144, 100, x square. So x square, subtract 100 both sides, it's 44. X, take square root. If I take square root of 44, it's going to be 6.6. So the radius, which is this length, going to be 6.6. There you go. So that was the second example. I have one more. So let's say I have one more to show you. Yeah. So, okay, since we know, okay, so that was, actually I have example number 4. Now, this is where we have to prove if the line is a tangent or not. As we just said, as we just talked about this. So, think about this. If there's a tangent line, and if it's a triangle. So in order to be a tangent line, isn't it that triangle has to be a right triangle? And how would you prove if it's a right triangle or not? So if that triangle satisfies this equation, then it would be a right triangle. And if it's a right triangle, it means this is a tangent point. Just because it's tangent, that's the reason it satisfies the right triangle identity, right? So that's what I'm going to show you next. So the problem is going to be something like, okay, so here's a circle. I see the center point at N. This is the radius. And here's a line, and here's a tangent line. So this line is 25, this is 24, and this is 7. So we need to prove if that line, which is labeled as, this is M, this is L, and this is N. So we need to prove if ML is a tangent to this circle. So how would you prove? So you can prove if it's a right triangle. If it's a right triangle, yes, it is a tangent. If not, then it's not a tangent. So how would you prove? So you need to use that a square equation. But now the problem is, what side you would set it equal, or what side would be the hypotenuse? So keep in mind, side across 90 degrees. This is definitely exactly a tangent point. That's where we need to assume that's where the 90 degrees is going to be. So side across always going to be the hypotenuse, okay? So I would say 25 square, 7 square, 24 square. So let's plug everything in. 7 square, 49. It's going to be 24. It's 576. And this is, okay, let's add. Yep, it is 625 and 625. Yes, it is true. All right. So that's how we prove. If at the end both sides are not equal, means it's not a tangent just because it's not a right triangle. Okay. And yeah, that's pretty much all. So thank you for watching. Bye-bye.